Welcome to tutorial combustion 4. Okay, in this tutorial we have another set of question where we have 100 mole of butane is burned with 20% excess air. Percentage of conversion of butane is 90. Determine the number of moles of components in the product stream. Okay, this tutorial is a bit different from the tutorial 3 and 2 because now the conversion of butane is only 90%, not 100%. So we look how we deal with this type of question. Okay, so we have information, so we plot in the information here. So we have our basis. So our basis is 100 mole butane fed into the furnace. So before we start our reaction question, we definitely have to write down the equation because we need the equation for our calculation. So we know butane react with O2, produce CO2 and water, and then we have to balance out. So we have the final equation, complete combustion. However, complete combustion, this is complete combustion process, but the conversion of butane is only 90%. So remember, that's two different things. Combustion is only 90%. The conversion of butane only 90%, but it is a complete combustion process where we are not where in the question does not say anything about production of CO. So we assume the process is complete combustion. So this is our reaction. Only one reaction because we assume it is complete combustion. So from this information, we plot down our process flow diagram. So we know we have one furnace. We know we have one line of going in of butane with 100 mole. And then we have another line of the air. But this air is actually with excess. This air line, the line for air, we split into two where we have number mole of oxygen and one number mole of nitrogen because it's easy to do it this way in this type of question. Okay, and then now the tricky part would be the putting down the unknowns for your product line. So when it says burn with excess air, so you definitely know you have excess of oxygen out together with your nitrogen which is not reacted, that goes out here. It says percentage of conversion of butane is 90. When you have only 90% conversion, so you expect to have excess, you have balance of unreacted butane here. And the other two compound in the product gas would be our carbon dioxide and also water. So we have 5 components in our product line. To start solving the question, so we will start with finding number mole of O2 that goes in. To get number of O2 goes in, definitely we have to start with the theoretical oxygen. We know to find theoretical oxygen, we have to use the number of mole of C4, the actual number mole of butane that goes into the process, and times it with the fraction between O2 and also O2 used with C4H then used from the reaction. So we'll get the theoretical oxygen in this process still 650 mole of O2. Okay, from there we calculate what is the O2 in using this equation. So this equation has been used in tutorial 2 and tutorial 3 as well. Okay, so you get the number of mole of oxygen that goes into the process. The actual number is actually 780 mole of O2. You require only 650 mole theoretically. However, because of you have 20% of excess air, which is similar to 20% of O2, so 600 end up you have mole of O2 is 780 mole of O2. This is with excess 20%. From this, you can obtain the number of mole of nitrogen because you use this information times with the relationship between nitrogen and O2, so you'll get number of nitrogen. This is nitrogen in. Nitrogen in will equal to nitrogen out. So nitrogen out, basically we have this number as well because it does not react. From the information of conversion of butane, so we'll know what is butane out. Butane out equivalent to 1 minus 0.9 times by 100. So we already know butane out that does not react, that goes out in the product line, is 10 mole of butane. To find the unknowns here at the product line, I would like to use the extent of reaction method, because I have enough information to get the extent of reaction. So to use extent of reaction, definitely we have to find the xi, or extent of reaction value. So I'll use butane balance to get the xi value, because I already know that from the conversion just now, I know unreacted that goes out in the product line, the butane that goes out in the product line is 10 mole. So balance unreacted 10 mole equivalent to 100 that goes in minus extent of reaction. So I obtain my xi, or extent of reaction, equivalent to 90 mole. As we say, conversion is 90%, so the reaction goes 90 mole. Okay, so using this information, I'll calculate the other unknowns. So for O2 balance, I'll get the number of O2 out. So I do not know O2 out. O2 out equivalent to O2 that goes in. O2 that goes in from the process, from air goes in, minus, because it's reaction, so minus 6.5 times by my extent of reaction. So I'll obtain the O2 balance equivalent to 195 O2 here. Using CO2 balance, I'll obtain the CO2 that goes out from the furnace, the CO2 that actually produced from the combustion, and CO2 out equivalent to 0, because no CO2 comes in the feed line. No O2 in the feed line. No CO2 in the feed line is only produced. So that's why feed is 0 plus 4 times the extent of reaction. 4 times with extent of reaction. So you obtain the number of CO2 produced is 360 mole of CO2. So for H2O balance, I'll obtain my H2O out, where my H2O out or produced equivalent to 0, which goes in, plus 5 extent of reaction. So I obtain water produced 450 mole of H2O. Okay. N2, as I said just now, is actually just N2 in. You just bring it out because it's not reacted. So this is how we solve for this type of question when we have this question. When this question is slightly different from tutorial 3 and tutorial 2, because we have conversion which is only 90%, not 100%. So this is how we do it. If you need to find the if you need to find the molar composition, then the molar composition of the product stream, so you have to find total number of mole and divide each compound number with the total number of mole, and then you will know the mole fraction or the molar composition of your compound in each stream. Your molar composition in the product stream. Thank you.